Good morning, Harry. Now remember, we did Wednesday, January 27th, obviously yesterday on Wednesday. We're on the Thursday, January 28th portion, which is mostly pages 264 to 265. We were introduced as to what weathering is, physical and chemical. Weathering, so yesterday you should have numbers 1 through 4 done. Today we're going to focus on numbers 5, 6, and 7. Give you a few examples of the types of weathering that we're talking about. So a lot of these first 7, 8 slides we're not trying to rush through, but we already went through them yesterday, so just kind of briefly go through them. This is the type of weathering that we're not really talking about. This is extreme quick weathering where Mount St. Helens erupts like a volcano, which Mount St. Helens is a volcano. It completely changes landscape. Not what we're talking about. Again, this is a before it erupted photo, an after it erupted photo. Completely changing really quickly. Not what we're talking about. We're talking more of a slower weathering process. No, not millions and millions of years like theory of evolution. Not at all. But it is a physical weathering that happens slowly on our Earth still today. All the time is happening. Chemical weathering is dealing with chemicals and how that changes. We'll talk about that. But this is all happening in all types of landforms, all over the world, all on the Earth's crust. That's what we're talking about. It's all on the Earth's crust. Now, here's some news slides that we're going to. This is a good example of physical weathering. You might have been hiking or up hunting and you see rocks with huge cracks in them. How in the world did it happen? How in the world can something so heavy and powerful come through and make a huge crack and a huge giant boulder? Well, something as simple as water. If you ever filled up ice cube trays and you put them in the freezer, you might have pulled them out an hour later when they're actually frozen below 32 degrees, and you might notice that it seems a little bit bigger than the amount of water you put in. When water freezes, it expands. So let's say there's a day where it's 40 degrees and it's raining. Well, all the water goes down, right? It always goes downhill. It might find cracks that it goes in. And if at night it gets below 32 degrees, that water is going to freeze. And when it freezes, it expands. And if there's only so much room for it to expand, it's literally going to be able to push the rock apart. And then the next day, if it gets to like 45 degrees, it'll melt again and keep flowing. But this might not happen overnight where it cracks this big, but over several years of rain getting in there, freezing, expanding, contracting when it goes back and melts into a liquid and goes on. But it can eventually make cracks so big that part of the rock falls down. That's physical weathering. That's taking a big, huge rock and splitting it into smaller rocks. Here's another way. This is what's happening. Now, this is actually quite evident if you take Highway 60 up the Salt River Canyon, right? You know you're going up to higher elevations where it gets a lot colder. And so there, it happens quite often where water gets in different cracks, it freezes, expands, and then when it melts, it turns back into water and goes down. But that's why some of these are such unusual shapes, is because of that physical weathering caused by water freezing, expanding, and then melting. That happens a lot there. Sometimes it just happens with tree roots. You guys maybe, and I know this isn't physical weathering because it's not the earth, but if you ever had tree roots get into some kind of water pipe, tree roots don't care. They're going where they want to go, and they can knock out entire water pipes. But in the physical weathering aspect, it can literally go right through rocks. I mean, take a look at this tree. It's rooted, and literally the tree roots go right in between the rocks, and they move them and they break them into smaller parts, just like you see here. That's an example of physical weathering. It's changing the surface, or it's changing rocks and break them into smaller parts. You might have seen different waterfalls. And again, I know I mentioned this yesterday, but Underneath that waterfall is a bunch of rock, and slowly but surely it's going to keep wearing down the rock and wearing down the rock and break off pieces and have it float down into the water below. Well, that's physical weathering. It's literally changing the rocks. Nobody's going there with a hammer or sledgehammer and breaking it apart. That's all the water doing that. Breaking into smaller parts. That's why a lot of times in a running stream you pick up a pebble and it's nice and smooth because the water's constantly wearing it down. Water does this a lot. Here's a picture of the Grand Canyon. Now, there's a lot of different erosion that you can see here, which is caused by water. What evolutionists will incorrectly say is over millions and millions of years, the Colorado River formed the Grand Canyon. Not true. Not true. Is there weathering going on at the bottom of the Grand Canyon? Yes, absolutely. Did it happen over millions of years? No. That's where it takes away glory from God, and we're not going there. We're always giving glory to God. We have different other examples where we can tell that water completely shapes or changes the land. Here again, I know these big rocks aren't constantly moving, but over time, not millions of years, but over hundreds of years, it can break this into smaller rocks and change the formation. Here's weathering by wind. Take a look at this huge rock. Well, the wind can whip so hard over this and blow a bunch of sand and start breaking away at the bottom that can literally wear away rock and shape the rock. This is all done by wind. Usually wind isn't powerful enough to change the feature, but we've seen wind with like hurricanes and tornadoes and how strong it can be. We've also had very windy days where you can tell, yep, if that happens long enough, it can absolutely change different parts of the world, and it has changed this rock by literally the wind blowing against it and wearing away different parts, and part of it is sand hitting it too. Glaciers are where it's very, very cold, but glaciers you can still go see up in Alaska and the North Pole and South Pole. And glaciers is literally a very slow-moving mass of ice. And you can imagine how much power there is here. And yes, it's moving so slowly, but it can literally change and scrape away the rocks. Here are some examples of rocks that were scraped at and broken apart by glaciers moving down. Still happens today, and it's physical weathering. Erosion might happen in your backyard. It happens on the school campus where we get water. Water always flows down hills, and water always finds the path of least resistance. In other words, the easiest way to go. And it can literally cut a path in the ground. And if it happens rain monsoon season after monsoon season after monsoon season, some of those can get really, really large and big and form these, albeit shallow, canyons, but that's caused by water. Physical weathering caused by things that just naturally happen on this earth. Rain, wind, and things like that. Mudslides are things that can completely change. I mean, here, man tried to form a road here, which they did, but they didn't push back the hill far enough, and it gets rainy and rainy and rainy. It can literally have part of the hill or mountain slide down because the ground is so unstable because it's so muddy that it just comes right down. That's called a mudslide. An avalanche is the same type of thing, just more with snow. That's powerful. It can change the different way that the land looks. It's physical weathering. You might hear a thing called deposition. What that means is where different rocks and particles of land are deposited. Here's an example. You can see here that this is a river meeting a larger body of water. Well, you might know that the river, as we learned, carries a bunch of different things from the land. Carries dirt and soil and rocks down, and that's what gets deposited in the ocean, which makes it so salty. Well, here we have all this land getting deposited through the river, and then we have this large body of water whose waves are crashing against it, and literally what happens is those land things that are carried by the river get pushed back by these strong waves and get deposited right here. That's what all this is. If you're wondering, like the Tin Man in The Wizard of Oz, who says, I wonder why the sea is always by the shore. Well, this lesson tells you it's because of physical weathering. Think of these waves and how powerful they are. And yes, there is still the Earth's crust underneath, or land underneath the ocean. There's also big rocks. If you look sand closely enough, what does it look like? Tiny, tiny rocks. That's because it is. Now it's really smooth because the water is constantly running over it and smoothing it down. But what is sand? Tiny little fragments of all the rocks and all the land that the ocean is bringing back up onto the shore. It's literally pounding it and depositing it on the shore. That is why the sea is always near the shore, there, Mr. Tin Man. But if you've ever been to the ocean or a large body of water, you know how powerful these waves are. So yes, that's still a big rock, but slowly but surely over time, it's still getting worn away and worn away and worn away, and little pieces are breaking off, and the ocean brings it and deposits it on the shore. That's kind of what this is telling you here. We have all this land running down through erosion and rainfall and the rivers and bringing all this land down, and then it gets slammed back onto the shore by the ocean waves, and it gets deposited here. And another example here, I didn't realize I had so many examples, but that's what's going on. All this land is coming down the river, and the ocean waters just push it up on shore. Now, here's chemical weathering. Chemical weathering is the same thing, breaking up rocks and other material into smaller parts. However, it's done with the chemical process. I'm not saying it's a strong chemical process. Like when we think of acid, we think, oh man, it's going to burn everything. Well, yes and no. That's what acid does, is break things down. Believe it or not, in your spit, in your saliva, you have some acid that actually helps break down your food. It's very, very weak acid, but it still is meant to do one thing: break down your food into smaller parts. Now remember, when we went to the digestive system, your teeth and chewing is going to help that out, but the saliva does two things. Makes it wet to go down your esophagus into your stomach, but also helps break it down into smaller parts. Because remember, your food has to get down into your bloodstream to every last cell in your body. That's how small it's got to be. Well, again, chemical weathering is some kind of chemicals or acid that got into a natural river or stream or the clouds and rain, and that also breaks down rocks and land through a chemical process. Doesn't mean that if there's acid rain, everything's going to burn. That's not what it is. It's just that there's certain chemicals that are weak but still break down rocks. One of the most things we're used to is rust. Now we're going to talk about this later, but this is oxidation, which basically means the chemicals in oxygen have reacted with this and changed it. You know, the metal that we originally got from rocks in the earth got this oxygen with chemicals in it, and it started to rust. All this brown and orange stuff happened. That's not how it was normally looking or made, but through the chemical reaction, rust was created, and then it gives out that orangish and brown residue. This kind of carbon dioxide, which is a lot of stuff that we breathe out when we breathe, can sometimes get in different water and streams and things like that. This is most prevalent when it gets into different streams and ponds inside of caves, meaning underground. Part of the reason is water gets in the ground and it goes through all these different types of land and rock, and it can pick up some of these chemicals like carbon dioxide, and it forms a very weak acid that's called carbonic acid. Now, you don't want to drink water with this, but it also, in most cases, is quite weak. However, it still has enough acid that it can literally wear away the rocks. That's what acid does, is it breaks things down, and it can actually break down rocks. So that's what's going on here. It's helping to break down the rocks and also in here. But we also have oxidation where it can react with the different chemicals in air, or it can actually go up and fall down with the rain, and it helps dissolve different things on rocks. Most prevalent is physical weathering, with water and wind and ocean waves and water freezing and things like that. But chemical weathering most definitely occurs too. It can also help you look at page 264 and 265. But your assignment for today, remember, is this Thursday, January 28th section, which is right here. It's numbers 5 through 7. If you didn't get these answers here, I strongly suggest you go back in the video or look at pages 264 and 265. If you look long and well, I guarantee you the answers are there as well. Hey guys, Lord's blessings to you today as you praise your Savior.